Good evening, everyone. Good evening. Welcome back. Quickly, let me know in the chats if I'm perfectly audible and visible to every one of you. Not visible, just audible, yeah? Let me know in the chats if you can hear me properly. Let me know in the chats, my dear people, if you can hear me. Hello, Samuel. Hello, Stefana. Hi, Praveen. Hello, Mohideen. Hi, Mohan. Hello, N.A. Welcome back, people. Welcome back. Quickly, let me know in the chats if you can hear me. Hi, Sanju. Hello, Fast and Furious. Hello, Joyce, Mary. Welcome, welcome back, welcome back. Just give me a second. I'll fix certain things and we shall be starting. Just give me a second, guys. Just give me a second. All right, people. So I welcome you all again back to your Vedantu and Enlite channel. I hope all of you are doing great, having a wonderful time. So my dear people, quickly give me some green signal from the chat so that I'll get to know I'm perfectly audible and visible to every one of you. Yes, hello Vimlesh. Hello Dr. Naziha Abdul. Hello Niyati. Hello Harun. Yes, the Avengers have assembled, yeah? I'm doing great, guys. I'm doing great. Thank you. So quickly, let me know in the chats if I'm perfectly audible and visible to every one of you. Samuel is saying Tony is reporting, sir. If you're Tony, then who am I? Huh? Who am I then? Perfect, guys. Perfect, perfect, perfect. So let me know quickly in the chats, first of all, if you guys revised the last session properly. Yeah? Well, you know, we have started the first chapter of your class 11 chemistry, that is the mole concept, and this session is for everyone whosoever is preparing for NEET 2024, NEET 2023, JEE 2024, as well as JEE 2023. This particular session is for everyone, right? Because the sessions are going to be in detail, right? If you remember, in the last session, we talked about something called as atomic mass, right? Then we understood molar mass as well as molecular mass as well. Those were the three terminologies which we discussed in the last session, my dear people. What all things we are going to cover in tonight's discussion? We shall be first of all talking about the average atomic mass of the element which has isotopes. Number one, that is the first topic which we are going to start with. Number two, we shall be doing the actual mole concept in today's session, right? We shall be seeing how to calculate number of moles of different substances and some important things. I mean, this particular session is going to be very, very, very important session as far as this particular chapter mole concept is concerned. Because I'm going to talk about those basics in this particular session which you guys are going to use in this entire chapter. So please and please do not miss even a single thing, right, from tonight's discussion. Perfect? Thank you guys. Thank you everyone. Thank you. Fast and Furious is asking for Menti quiz. Menti quiz will be doing once we'll be done with this particular chapter, right? Once we finish the chapter, then there'll be one session in which we'll be doing the Menti quiz, right? And in the Menti quiz, I shall be asking you the previous year questions from this particular chapter, right? Perfect, guys. So before starting this particular session, the ones who have just joined in, the ones who are new to the channel, I'll just quickly introduce myself. So people, my name is Wassim and I'm your chemistry master teacher right here on this Vedantu and Enlite channel, right? I train students for IT JEE as well as NEET, right? On this particular channel as well as on actual Vedantu platform, yeah? So before starting the session, my dear people, the ones who have not liked the video yet, please and please do like the video, share the video with everyone, right? Whosoever is preparing for NEET or JEE 2024, 2023, whatsoever examination, whosoever is preparing for, just share this particular video with everyone. Let everyone get benefited out of these sessions which we take on this particular Vedantu and Enlite channel, right? And at the same time, do not forget to subscribe to the channel as well. And at the same time, do not forget to hit the bell icon as well, so that you remain notified about the sessions, so that you get the notification of all the sessions which we take live on this particular Vedantu and NEET channel, right? Perfect. All right, people. So quickly, let me know in the chats, first of all, if all of you are super duper excited about this particular session as well. Yeah? Harun, I cannot give you the exact date, but let me tell you that in the next session, right? I'll figure it out. I'll let you know in the next session. So quickly, my dear people, let me know in the chats if all of you are super duper excited about this particular session as well. Yes? Quickly, let me know in the chats. And as I keep on telling you all the time, whatever I'll be mentioning on the screen, whatever I'll be writing on the screen, I would want you guys to make the running notes. Please and please note down every single thing, whatever I'm going to write on the screen. Yeah? Perfect. Let's get started then. Perfect. So my dear people, let's get going and let's talk about the first topic of tonight's discussion. That's going to be the average atomic mass, of the isotopic mixture. Which is represented by MAV. This is the topic which we shall be doing first. Important topic, average atomic mass of the isotopic mixture. First of all, before starting, if I ask you what isotopes exactly are all about, what are isotopes exactly? If I ask you, let me tell you, isotopes are basically the atoms. Isotopes are basically the atoms of same element, having same atomic number, but different mass numbers. I'm sure every one of you would have come across this particular term in your earlier class as well, right? Isotopes are basically the atoms of same element which have got same atomic number but different mass numbers. For example, if I talk about hydrogen, right? Let me tell you, there are 3 atoms of hydrogen which have got same atomic number, 1, and different mass numbers, right? Over here, these are the atomic numbers, and over here, these are the mass numbers. Can I say these are the 3 atoms of hydrogen which have got same atomic number but different mass numbers? Absolutely. So I shall be calling these 3 atoms as isotopes of hydrogen, right? In the similar way, if I talk about chlorine, let me tell you, there are 2 atoms of chlorine which have got same atomic number but different mass numbers. This is 35, this is 37, right? So I'll say these are basically the atoms of chlorine which have got same atomic number but different mass numbers. So I shall be calling these 2 atoms as isotopes of chlorine, right? For example, I talk about magnesium, right? For example, I'm talking about magnesium. If I write something like this, 12 here, 12 here, and 12 here, and over here I'm writing 24, over here I'm writing 25, over here I'm writing 26, right? Can I say these are the 3 atoms of magnesium which have got same atomic number but different mass numbers? So I shall be calling these 3 atoms of magnesium as the isotopes of magnesium, right? So first of all, what are isotopes? I must say isotopes are exactly the atoms of same element which have got same atomic number but different mass numbers, right? I'm sure this is something which will be clear to everyone. Point number 1. Point number 2, my dear people. Point number 2. Let me erase this definition. I'm sure this is clear. Now comes the actual stuff. See, let's assume I have got an element X. Let's assume I have got an element X. And let's assume this element X has got 2 atoms which have got same atomic number but different mass numbers. This is M1 and this is M2, right? Do remember, my dear people, whenever the element has isotopes, whenever an element has isotopes, for that particular element which has isotopes, we do not calculate the normal atomic mass for that particular element, we calculate average atomic mass for that element, right? We calculate average atomic mass for that element. And in order to calculate the average atomic mass of the element, what do we need? We need something called as percentage abundance. We need something called as percentage abundance. Now the point is, what is percentage abundance? I'll make you understand this percentage abundance in some time. First of all, remember, whenever the element has isotopes, for that particular element which has isotopes, we do not define its normal atomic mass. We calculate its average atomic mass. And in order to calculate the average atomic mass of an element which has isotopes, what do we need? We need the percentage abundances of its isotopes, right? Now I'm assuming the percentage abundance of this particular isotope is A and the percentage abundance of this particular isotope is B. If you got the percentage abundances of these isotopes, then you can simply make one formula to calculate the average atomic mass of an element which has isotopes, right? And the formula is simple, going to be M1 multiplied by A plus M2 multiplied by B divided by A plus B, right? So it's simply going to be M1 multiplied by A plus M2 multiplied by B divided by what? Divided by A plus B. Perfect, right? Now the point is, you must be thinking what this percentage abundance is all about. Before making you understand the concept of percentage abundance, let me tell you one more thing. Right? See. Let me tell you one more thing. Have a look, guys. Let's assume I've got the element X, right? I'm assuming this element has got 3 atoms. This element has got 3 atoms which have got same atomic number but different mass numbers. This is M1, this is M2, and this is M3, right? And my dear people, as I told you, whenever the element has isotopes, we calculate average atomic mass for that particular element. And in order to calculate the average atomic mass, what do we need? We need the percentage abundances of its isotopes, right? Let me assume the percentage abundance of this particular isotope is A, this one is B, and this one is C, right? Now I'm simply going to make a formula to calculate the average atomic mass of this X over here. And what is the formula going to be? It'll be M1A plus M2B plus M3C divided by A plus B plus C, right? So the formula which I'm making over here is going to be M1A plus M2B plus M3C divided by A plus B plus C, right? So this is the formula which you'll be using in order to calculate the average atomic mass of the element which will be having 3 isotopes, right? Let's say you have got the element which has 4 isotopes. So how you will be modifying this formula? In the numerator, you'll be writing M4D. In the denominator, you'll be adding one more term. That's going to be D, right? Now you must be thinking what this percentage abundance is all about and where do we see these things, right? Where do we use these things? Yeah? Perfect. Yes, Mohan, I'll be doing that. No issues. So my dear people, let's get to know what this percentage abundance is all about and where do we use this concept. Have a look. I'm sure every one of you would be familiar about chlorine, right? Every one of you would be familiar about chlorine. If I ask you, how many isotopes this chlorine has? You must say, chlorine has got some 2 isotopes. Chlorine has got some 2 isotopes. One is Cl35, one is Cl37, right? Chlorine has 2 isotopes, right? Now, if I ask you, what is going to be the average atomic mass of chlorine? You should answer me, in order to calculate the average atomic mass of chlorine, we must have percentage abundances of its isotopes. We must have percentage abundances of its isotopes, right? And my dear people, experimentally it's observed that the percentage abundance of this Cl35 is 75 and the percentage abundance of Cl37 is 25. Now what is meant by this 75 and 25? Look here, understand. Imagine in nature there are only 100 chlorine atoms. Imagine in nature there are only 100 chlorine atoms, right? Now, among those 100 chlorine atoms, some of the chlorine atoms will be in the form of Cl35 and some will be in the form of Cl37, right? Now let me tell you, since you know the percentage abundances of these isotopes, right? So you can clearly say out of those 100 chlorine atoms, 75 chlorine atoms will be there in the form of Cl35 and 25 chlorine atoms will be there in the form of Cl37. So in general, whatever chlorine exists in nature, 75% of the chlorine atoms you'll find in the form of Cl35 and 25% of the chlorine atoms you'll find in the form of Cl37, right? I hope you got it. Yeah, 75% of the chlorine atoms you'll find in the form of Cl35 in the nature. Similarly, 25% of the chlorine atoms you'll find in the form of Cl37, right? Since I gave you the percentage abundance of these isotopes, and you know, percentage abundances are represented by A and B respectively, right? So my dear people, should I be calling this as M1? Should I be calling this as M2? Absolutely, I can call them as M1 and M2, yeah? Now you can clearly make a formula to calculate the average atomic mass. It's going to be M1A plus M2B divided by A plus B, right? Now what is the value of M1? M1 value is simply 35. What is the value of A? A value is 75, right? Similarly, M2 value, that is 37, and B value is 25 divided by A plus B. Divided by A plus B. A plus B over here comes out to be 100, right? And when you solve this, the value comes out to be exactly 35.5, and you're going to write its units. It's going to be AMU, right? So if I ask you what this 35.5 over here is, you'll answer me this 35.5. It is basically the average atomic mass of chlorine, right? Yes, my dear people? Yes, you can watch it for NEET. If you're NEET 2023 student, you can watch it as well, no issues, right? Perfect, my dear people. I'm sure this is super clear to everyone, right? Do remember one more thing from here. Have a look. The percentage abundance of Cl35 was 75 and the percentage abundance of Cl37 was 25. If you add these two terms, 75 plus 25, how much it comes? 100, right? So you can generalize the statement, the sum of percentage abundances. The sum of percentage abundances of all the isotopes. The sum of percentage abundances of all the isotopes of a particular element. Is always going to be equal to what? Is always going to be equal to 100. As simple as that, right? Perfect. Now, my dear people, what kind of questions are asked from this particular concept, right? Let's try to understand what kind of questions can be asked from this particular concept in your NEET or JEE examination, right? Let's start with the simplest one. Yeah? All right, one more thing which I would want to share. Let me tell you, normal atomic mass of an element can never be fractional. It is always the average atomic mass. It is always the average atomic mass which comes out to be fractional, right? Average atomic mass can be fractional. Normal atomic mass can never be fractional, right? Do remove that thing as well. Now, where do we use this concept? I'm writing a simple question over here, and I would want you guys to give it a try first, then I'll try to solve the question on the screen, right? The question is simple. I'm writing something as chlorine has two different isotopes. Chlorine has, or let me write it simple, chlorine has two isotopes. Cl35 and Cl37. The average atomic mass of chlorine is 35.5 AMU. Calculate the percentage abundances of its isotopes. Calculate the percentage abundances of its isotopes. I would want you guys to use the procedure, use the formula, then solve the question. I know you guys know the answer. Answer is going to be 75 to 85, right? But I would want you guys to solve it with the help of formula, right? So that you get to know exactly how do we and where do we use this concept, right? Yes? Yes, Sahil, exactly. It started. Jaya, it's all experimental stuff. Alright, my dear people, have a look exactly how am I going to deal with this particular question. It's a very simpler one, right? You just need to use a little concept here, right? Just to solve this particular question. Understand? See, if I talk about chlorine first of all, as far as the question is concerned, chlorine has two isotopes. One is Cl35, another one is Cl37, right? Well, my dear people, the average atomic mass of chlorine is given to us as 35.5. This is something which is given to us. Perfect. What are we supposed to calculate? We are supposed to calculate the percentage abundances of its isotopes, right? Now, my dear people, as I told you in the beginning itself, the sum of percentage abundances of all the isotopes of a particular element, that's always equal to 100, right? Now, let's assume the percentage abundance of Cl35 is X. If the percentage abundance of Cl35 is X, that automatically means percentage abundance of Cl37 is simply going to be 100 minus X. As simple as that, right? Because we know the sum of the percentage abundances of all the isotopes of a particular element, that's always equal to 100, right? Yes. So I assumed the percentage abundance of Cl35 as X and percentage abundance of Cl37 as 100 minus X, right? Perfect. So my dear people, now just use the formula. Should I be first of all calling this as M1? Should I be calling this as M2? Right? And you know, percentage abundances, they are represented by A and B respectively, right? So A value is X, B value is 100 minus X. So I shall be using the formula instead of M average. Can I write M1A plus M2B divided by A plus B? And this value is coming out to be exactly 35.5. As simple as that, right? Now, my dear people, M1 value, you know, that's 35. A value, you know, that's X. M2 value is 37. B value is simply 100 minus X. Divided by what? Divided by A plus B will anyways come out to be 100 because the sum of percentage abundances, right? And this value is equal to 35.5. Yeah? Now, you just need to cross multiple, right? And I know, I'm sure you guys know how to do the cross multiplication, right? And after doing the cross multiplication, you are getting the value of X as 75. If value of X comes out to be 75, so 100 minus X comes out to be 25, right? And what was this X and 100 minus X? This was basically the percentage abundance of Cl35, and this was the percentage abundance of Cl37, which we were supposed to calculate as far as the question was concerned, right? I'm sure you got to know how do we tackle this sort of a question. Isn't it simple, my dear people? Quickly, you guys can let me know in the chats. Quickly, you guys can let me know in the chats if you can solve this sort of a question on your own from now onwards, yeah? I'm looking at your chats only. Let me know quickly in the chats. Then only I can give you one more question based on the same concept. Quickly, let me know in the chats if it is super clear to everyone. Right, people? All right, wonderful. Perfect. Let me give you one more question. Let's try to solve one more question from the same concept, yeah? Understand properly. See, guys, for example, the question is like this. I'm writing the question for you so that you can solve it. The question is, for example, magnesium has 3 isotopes. Magnesium has 3 isotopes: Mg24, Mg25 and Mg26. These are the 3 isotopes of magnesium, right? The percentage abundance of Mg24 is equal to 79 and average molar mass of magnesium, average atomic mass of magnesium is equal to 24.31. Calculate the percentage abundances of Mg25 and Mg26. This is the question on the screen. Let's give it a try and let's get to know how to solve this particular question. I would want you guys to give it a try and let me know its answer. But if you give it a try right now, it's going to take time. So it's better if you look exactly how am I going to approach this sort of equation and remember the approach of the question. That's something which I want from you, right? Yes, Naresh. Yes, exactly. Shreya sir is your Steve Rogers and Wassim sir is our Thor. Yeah? This is my hammer. All right. Let's have a look exactly how this sort of equation is to be solved, my dear people. Understand properly what I'm going to say. See, first thing, as far as the question is concerned, the element that's given to us, that's magnesium, right? And as far as the question, magnesium has got some 3 isotopes. As far as the question is concerned. One is your Mg24, another one is your Mg25, another one is your Mg26. These are the 3 isotopes of magnesium which we are given with, right? Now, my dear people, one more thing. As far as the question is concerned, the average atomic mass of magnesium is also given to us as 24.31. This is the average atomic mass of magnesium that's given to us, right? Now, my dear people, at the same time, one more thing is given. The percentage abundance of Mg24, that's given to us as 79. This is the percentage abundance of Mg24. And what are we supposed to calculate exactly? We are supposed to calculate the percentage abundance of Mg25 and Mg26. Can we do it? Yes, we can do it. How come we are going to approach to this question? Have a look. Same concept. As I told you a few minutes back only, I told you the sum of percentage abundances of all the isotopes. The sum of percentage abundances of all the isotopes of a particular element, that's always equal to 100, right? Yes. Now, my dear people, if the percentage abundance of Mg24 is 79, what does that mean? That means the percentage abundance of Mg25 and Mg26, right? The percentage abundance of these two in the combined form, it's going to be 100 minus 79, that means 21%, right? If the percentage abundance of the first one is 79, that means the percentage abundances of these two, right, will be simply 21%, right? Now I'm assuming the percentage abundance of Mg25 as X, that means the percentage abundance of Mg26 is simply going to be 21 minus X. Is this step clear to everyone, right? This is supposed to be clear to everyone. The percentage abundance of this one is 79. That means the percentage abundance of these two isotopes will be 21. And in 21%, let's assume the percentage abundance of Mg25 is X. So Mg26 percentage abundance is going to be 21 minus X. As simple as that, right? Now, my dear people, now you know the formula and everything. This is basically the value of M1. This is basically the value of M2. This is basically the value of M3, right? And this is something which I'll be representing with A. This is something which I'll be representing with B. And this is something which I'll be representing with C. And you already know the result which I gave you a few minutes back only. Instead of MAV, can I write M1A plus M2B plus M3C divided by what? Divided by A plus B plus C. And A plus B plus C value, that's always equal to 100, you know it, right? And this value is equal to 24.31, yeah? Now, my dear people, if I ask you what is M1, M1, you know that's 24. What is A? M1 is 24. M1 is 24. What is A? A is basically 79, right? M2, that is 25. B is X. M3 is 26. And C is 21 minus X, right? Divided by what? Divided by 100. And this value is coming out to be exactly equal to 24.31, right? Now, my dear people, if I ask you, just do one thing, just do the cross multiplication. And when you do the cross multiplication, you will be getting one equation which contains one variable, that's x, right? You'll be getting, after cross multiplying things, you'll be getting one equation containing one variable, and when you solve that particular equation, you will be getting the value of x exactly equal to 11, and you'll be getting the value of 21 minus x as 21 minus 11 comes out to be 10. And what was x basically? X, I had assumed the percentage abundance of Mg25, and this 21 minus x, this was the percentage abundance of Mg26, which we were supposed to calculate. As simple as that, right? Perfect. Yes, Ashwin, you will be getting, just put a mail on Vedantu Care, right? If you have filled the criteria, if your attendance will be more than 75, and if you had solved 75% of the assignments, and after doing that, if you could not crack the JEE examination, your fees will be getting refunded, right? If you are fulfilling that criteria, you have to put a mail to VCare, they'll be definitely following it up, right? Yes, people? Quickly let me know in the chats if it is clear. Atomic structure, when is it going to get started? Atomic structure, we are going to start after this chapter. This chapter is going to take some 4 more sessions, right? And after this chapter, we'll be starting the atomic structure. Right, people? And if you want to see the atomic structure as well, I mean, I have already taught the atomic structure. I'll show it to you. Just a second. Just a second. If you really want to see it right now, perfect. If there is some sort of urgency, then do one thing. Search atomic structure by Wassim sir. You will be getting a lot of links, right? See, these are some 12 videos of atomic structure. Let me see. Yeah, this is the first lecture. This was for NEET 2023 students, and this JEE students can also watch. JEE students can also watch this lecture, right? This was the atomic structure lecture number 1. If you want to see right now only, I mean, you can watch it. Or if you want to wait, right, you can wait and then join me when this chapter ends, yeah? It's okay, Spark. Perfect, guys. This is what I'm teaching here. I don't know. Millikan's oil drop experiment. Okay. Nice. Good. What is this one? Properties of anode rays. Discovery of neutron. Rutherford's alpha particle scattering. Distance of closest approach. Anyways, okay, leave it. So you guys can watch it afterwards, right? If you want to watch it before itself. Okay. So, is this concept clear to you, my dear people? Is the average atomic mass of the isotopic mixture clear to you? For organic chemistry, you can consult MS Chauhan. MS Chauhan for NEET. Perfect, guys. So let's move on then. Let's start the basic mole concept now. Till now we did some atomic mass, molar mass, molecular mass, average atomic mass. Now it is the time to go to the actual stuff, which is really, really very important, right? So try to understand all the things which I'll be telling you now, right? So you guys mark the heading as, just mark the heading as calculation of moles. Just mark the heading as calculation of moles. How do we calculate the number of moles? How do we calculate the number of moles of a particular substance, right? See guys, I'll be directly giving you some 3 results which you guys are going to remember in order to calculate number of moles of a particular substance. 3 results I'll be giving you to calculate number of moles of a particular substance, right? Result number 1. Result number 1. Number of moles of the substance, which I'm representing with N, right? Or I'll be writing it exactly, number of moles of a substance, which I'm representing with N. Do remember, it's always equal. It's always equal. Given mass of the substance, it's always equal to given mass of the substance in grams divided by molar mass of the substance in grams per mole. How do we use this result? How do we use this expression? Understand what I'm going to talk about. For example, over here I'm writing a statement. I'm writing 160 grams of NaOH. For example, I have got a container, and in this container I'm keeping some 160 grams of NaOH. I need to know how many moles of NaOH are there in the container. How many moles of NaOH are there in the container? Yeah? Now, my dear people, if I ask you, are we given with the mass of this particular substance? Yes, we are given with the mass of this particular substance. And whenever you will be given with the mass of the substance, you just need to do one thing. You just need to divide the given mass of the substance by the molar mass of the substance. That's all. To calculate the number of moles. So if I ask you what is the given mass of the substance, it's 160 grams divided by what is the molar mass of NaOH. See, sodium has 23, oxygen has 16, hydrogen has 1. So molar mass of NaOH comes out to be 40 grams per mole. This is the molar mass of NaOH. So just divide it with 40. The value exactly comes out to be 4. That means there are basically 4 moles of NaOH present in this particular container. As simple as that. For example, I'm writing one more statement. I'm writing, for example, 64 grams of CH4. 64 grams of CH4. Let's assume I have got a container which contains some 64 grams of CH4. Now I need to calculate how many moles of CH4 are there in the container. Now first of all, understand what is given to us. Are we given with the mass of CH4? Yes, we are given with the mass of CH4. Whenever mass of the substance will be given and you are supposed to calculate number of moles of the substance, what you are supposed to do? Given mass of the substance divided by molar mass of the substance, right? The value again comes out to be 4. That means there are 4 moles of methane present in this particular container. So this is the first result, my dear people, by means of which you can calculate the number of moles of a particular substance, right? As simple as that. First result. Talking about the second result. Have a look. The second result is again very simple. Have a look. The second result says number of moles of the substance. Number of moles of the substance, which we represent with N. That's always equal given number of particles. Particles can be your atoms or molecules. Given number of particles divided by Avogadro's number, and I'm sure you exactly know the value of Avogadro's number, which is 6.022 into 10 raised power 23. Now the point is, how do we exactly use this particular formula? It's again very simple. Have a look. First of all, when do we use this particular formula? When do we use the second formula? Whenever number of atoms or number of molecules of a substance will be given to us, or in general I say, whenever number of particles of a substance will be given to us, you just need to divide the given number of particles of the substance by Avogadro's number, you'll be getting the number of moles. How do we use it? Thank you, Pranav. Thank you so much. How do we use it? Have a look. For example, my dear people, I'm writing something like this. 24 multiplied by 10 raised power 23 atoms of carbon. For example, I have got a container which contains these many atoms of carbon, right? Yeah? I've got a container which contains these many atoms of carbon. Perfect. Now, first of all, just have a look. Are we given with the mass of carbon? No. What are we given with? We are given with the atoms of carbon. That means we are given with the particles of carbon. Whenever we shall be given with particles of any substance and we shall be supposed to calculate number of moles of that particular substance, how we are going to do that? By following the second relation. I'll say number of moles of carbon is going to be equal to given number of particles divided by Avogadro's number, which approximately I can take as this much. So this and this got cancelled, the value comes out to be 4. So basically there are 4 moles of carbon in this particular container, right? There are 4 moles of carbon in this particular container. Or if I write something like this, I'm writing 48 into 10 raised power 23 molecules of water. Let's assume these many molecules of water are there in the container. let's say these many molecules of water are there in the container, right? I need to, for example, calculate the number of moles of water which are present in this container. How will I be doing that? First of all, you need to check. You need to check, first of all, whether we are given with the mass of water or we are given with the number of molecules of water. We are given with the number of molecules of water, right? That means we are given with the particles. And whenever we'll be given with the particles, what do we do at that time? Given number of particles, you just need to divide it with the Avogadro's number. You'll be getting the number of moles, right? And number of moles over here comes out to be 8. That means there are 8 moles of water present in this particular container, right? Yes? Yes, Bhardwaj, you can do that. Right? Perfectly done. This was the second result by means of which you can calculate number of moles. Now, my dear people, third result. Third result. Number of moles. Number of moles of a gas. Number of moles of a gas at STP. STP stands for standard temperature pressure. STP stands for standard temperature pressure. What is meant by that? It is basically a condition at which temperature of the gas is kept as 0 degrees centigrade and pressure of the gas is kept as 1 bar. Whenever I'll be having a gas in a container, if I keep temperature of the gas as 0 degrees centigrade and pressure of the gas as 1 bar, I can clearly say the gas is present at STP. So from now onwards, whenever I'll be using the term that the gas is present at STP, understand the temperature of that gas will be 0 degrees centigrade and pressure of that gas will be 1 bar, right? So my dear people, this particular formula, this particular result to calculate number of moles, it's only valid for gases and the gas has to be present at STP, right? So the formula is something like this. Given volume of the gas in liters divided by 22.4 liters, right? You can use 22.4. Perfect, no issues at all. Given volume of the gas in liters divided by 22.4 liters. This is the formula which you will be using in order to calculate number of moles of the gas which will be present at STP, right? Or you can use it like this. Given volume of the gas in milliliters divided by 22400 milliliters. Now the point is, how do I use this particular formula? How do I use this particular formula, right? See guys, see what you guys are going to do. For example, I'm writing a statement. Statement is something like this. 67.2 liters of carbon dioxide gas at STP. 67.2 liters of carbon dioxide gas at STP. For example, you have got a container and in that container, you are keeping some 67.2 liters of carbon dioxide gas at STP. And for example, you need to calculate number of moles of carbon dioxide gas, right? You need to calculate how many moles of carbon dioxide are there in the container. Understand? Are we given with the mass of carbon dioxide? No. Are we given with the number of molecules of carbon dioxide? No. Are we given with the volume of carbon dioxide? Yes. We are given with the volume of carbon dioxide. And whenever volume of the gas will be given, you just need to divide the given volume of the gas with 22.4 liters. You will be getting the number of moles. So basically there are 3 moles of carbon dioxide gas present in this particular container right now. Yeah? Perfect, my dear people. Very simple. For example, if I say there are some 44.8 liters of sulfur dioxide, SO2 gas at STP. Calculate the moles of sulfur dioxide. Calculate the moles of sulfur dioxide. So first of all, just understand, you are not given with the mass of sulfur dioxide, you are given with the volume of sulfur dioxide, right? And whenever volume of the gas at STP will be given, you just need to divide the given volume of the gas with what? With 22.4 liters, you'll be getting the number of moles. So there will be 2 moles of sulfur dioxide present in the container. As simple as that, right? Perfect. Right, people? Absolutely. Now comes the actual scenario. See what is the scenario. I'm going to give you one diagram. Which you need to remember and apply to solve the basic, simple questions of the mole concept, right? There are some basic, simple questions which you need to learn how to solve, then only we can go to the actual stuff in the mole concept, right? And the actual stuff in the mole concept starts from tomorrow, right? That will be stoichiometry. Perfect. Do not miss that session as well. And whatever I'm teaching right now, it forms the basis of your stoichiometry. Perfect. Now guys, have a look. There is one diagram which I'm going to give you, and you need to remember this particular diagram. See, over here I'm writing number of moles. Over here I'm writing number of moles. My dear people, how many ways are there to calculate number of moles? Hello Karthik, welcome. How many methods are there by means of which we can calculate number of moles? There are 3 ways by means of which we can calculate number of moles as of now, right? Number 1, if we are given with the mass of the substance in grams, we can calculate number of moles. And how do we do that? Just divide the given mass of the substance by molar mass of the substance. You will be getting the number of moles, right? Divide the given mass of the substance by the molar mass of the substance, you'll be getting the number of moles. As simple as that, right? Now at the same time, if I do the reverse, see, we know number of moles of the substance is equal to given mass of the substance in grams divided by molar mass of the substance, right? Now if I do the reverse, for example, if number of moles of the substance will be given to us and molar mass of the substance, we know if I just multiply these two, I'll be getting the given mass of substance. That means if number of moles of the substance are given and mass of the substance is to be calculated, you just need to multiply the number of moles of the substance by its molar mass, right? Just multiply the number of moles of the substance by its respective molar mass, you'll be getting the mass of the substance, right? As simple as that. Now at the same time, there is one more way by means of which we can calculate number of moles. I told you that. I'm writing given number of particles. And these particles can be your atoms, molecules, etc. Whenever we are given the number of particles and we are supposed to calculate number of moles, how do we do that? Just divide the given number of particles by Avogadro's number. Divide the given number of particles by Avogadro's number, you'll be getting the number of moles. In the similar way, if number of moles are given and number of particles are to be calculated, just multiply the number of moles by Avogadro's number, you'll be getting the number of particles. As simple as that, right? Now, my dear people, the third and important, that is, if volume of the gas at STP is given, and you are supposed to calculate moles of the gas, you're simply supposed to divide the given volume of the gas by 22.4 liters, you will be getting number of moles of the gas. And vice versa, if number of moles of the gas are given and you're supposed to calculate its volume, you'll be multiplying number of moles of the gas by 22.4 liters, then only you'll be getting the volume of the gas in liters. This is one simple diagram which you guys need to remember. And where do we apply this diagram? Understand properly what I'm going to say. Say guys, for example, I'm writing one simple question over here and you will understand how and where this diagram is applied. Yeah? Right? Say, for example, the first question I'm writing. Calculate the mass of 67.2 liters of carbon dioxide gas at STP. Very simple and basic question, right? Calculate the mass of 67.2 liters of carbon dioxide at STP. Now, my dear people, understand what is meant by this question. The question says you have got a container and in this container you are keeping some 67.2 liters of carbon dioxide at STP. You need to tell me what is going to be the mass of 67.2 liters of carbon dioxide at STP. How much is going to be the mass of this? We need to calculate the mass, right? Now, see how to approach this sort of a simple question. First, understand from the question what is given in the question and what we are supposed to calculate, right? Yes? Yes? Yes, Dushal, yes, you're right. So, my dear people, what I would want you guys to do right now, first of all, understand what is given to us and what are we supposed to calculate. See, first of all, calculate the mass. We are supposed to calculate the mass. We are supposed to calculate the mass of the substance, right? And what are we given with? We are given with the volume of the substance. Volume of the substance is given. and mass of the substance is to be calculated. Well, do you see any direct arrow between these two? No, there is no direct arrow between these two, right? Yes, people? Now, if I ask you, how do we solve this question? There is no arrow between these two. Now, people, do remember one thing. We are given with the volume of the gas and we are supposed to calculate the mass of the gas. Whatever quantity will be given to us, like in this question, volume is given to us. Like in this question, volume is given to us. Whatever quantity will be given to us will be starting with that quantity in the diagram, and we shall be ending at what is to be calculated. And in this question, mass is to be calculated. So we shall start from volume, we shall end at mass. And we shall be following all those arrows which are going to take us from volume to mass, right? That means which all arrows I need to follow. First of all, I need to follow this arrow, then only I can reach to moles. Then I need to follow this arrow, then only I can convert that into mass, right? So these two arrows I need to follow, then only I can convert volume into mass, which is something I need to calculate as far as the question is concerned, right? Yes? So people, my first step is going to be just convert the volume into moles. So my first step is going to be calculation of number of moles of carbon dioxide. It will be equal to given volume of carbon dioxide in liters divided by what? Divided by 22.4. Divided by 22.4, the value comes out to be 3. And this 3 is basically the value of number of moles, right? This 3 is basically the value of number of moles. And my dear people, you now need to multiply the number of moles by the molar mass of the substance. You'll be getting the mass, right? So I'll say mass of carbon dioxide. Mass of carbon dioxide in grams will be equal to, you just need to follow this arrow. Multiply number of moles by the molar mass. Number of moles of carbon dioxide multiplied by molar mass of carbon dioxide, right? So if I ask you, how many moles of carbon dioxide we got? 3. What is the molar mass of carbon dioxide? You'll say 44 grams per mole. The value comes out to be 132 grams. So what does it mean exactly? That means in the container, if you will be having some 67.2 liters of carbon dioxide, its mass is going to be 132 grams. As simple as that, right? Yes? Perfect, guys. Is it clear to everyone? Is it clear to everyone? Quickly, let me know in the chats. Let me know quickly in the chats if it is clear to everyone. Then only I can give you one more question, which will make this clear to everyone, right? Yeah? Perfect, guys. Wonderful. All right, I'm giving you one more question, which will make better understanding of this particular diagram which I gave you. See. Have a look, people. The question is something like this. Calculate calculate the number of molecules. Calculate the number of molecules present in, for example, 44.8 liters of carbon dioxide at STP. This is the question which I'm writing on the screen, right? Now, the first thing which you need to understand, just identify what is the given quantity and what is something which we are supposed to calculate. See, my given quantity is volume over here, and what am I supposed to calculate? I'm supposed to calculate molecules. Molecules means particles. So I'm supposed to calculate particles, right? And what is given? Volume is given. Volume is given, particles are to be calculated. So I shall be starting from volume and I shall be ending at number of particles. And I will be following all the arrows which will take me from volume to number of particles. How? First, I shall be following this arrow and then I shall be following this arrow, right? So these are the two arrows which are to be followed. So what should be my first step? My first step is to divide the given volume. Divide the given volume of the gas by 22.4, you'll be getting the number of moles. So my first step is number of moles of carbon dioxide, right? Will be equal. Given volume of carbon dioxide, that is 44.8 liters divided by 22.4 liters. The value comes out to be exactly 2. So what is this 2 over here? This 2 gives you basically the number of moles of carbon dioxide. So we got the moles, right? Now these moles are to be multiplied by Avogadro's number. You'll be getting the number of molecules, right? So I'll say number of molecules. I'll say number of molecules of carbon dioxide shall be equal to number of moles of carbon dioxide, right? Number of moles of carbon dioxide multiplied by Avogadro's number. right? So 2Na is going to be the final answer of the question. Yeah? Or you can put the value of Na as well, 6.022 into 10 raised power 23. The final answer is going to be 12 point something into 10 raised power 23. Those many molecules will be present in 44.8 liters of carbon dioxide. As simple as that, right? Isn't it clear, my dear people? Very simple and basic at the same time. Yes? Clear to everyone? Wonderful. So I'll be giving you one homework question. Just give that a try, and rest of the things we shall be discussing in the next session. Okay? I'm giving you a homework question. Let me know its answer in the comment section of the video right after the session ends. The question is like this. Calculate the mass of 48 into 10 raised power 23 molecules of SO2 gas at STP. This is the question which I'm giving you as the homework. Please and please do give it a try and let me know the answer of this particular question in the comment section of this particular video, right? And my dear people, after this, the rest of the things we shall be discussing in the next session, and at the same time there is something very interesting, important, which I need to tell you. So basically on 8th of August, that means on Monday, we are launching the NEET 2024 2-year complete batch, right? On the actual Vedantu platform. Perfect. In which your class 11th, class 12th, crash course, every single thing will be completed. You will be staying with us for complete 2 years on the actual Vedantu platform. And we shall be training you personally on all the subjects, right? In all the subjects. Apart from the syllabus completion, you need not to worry about the study material. You'll be provided with the finest study material across the country. That's called as Vedantu Tattva material, right? Perfect. And apart from the study material, which is one of the finest study material across the country, my dear people, if you are following that study material, you need not to follow any other book, right? You need not to follow any other book if you are following that study material. Yeah? And at the same time, no need to worry about the test series, no need to worry about the assignments, right? Recording of every live session will be there, right? All the features, all the important things, all the important parameters which are needed to crack NEET 2024 examination with a really good score, all those parameters are incorporated in this particular batch. And my dear people, in this particular batch, what we guys are going to have, you are going to get trained by those teachers across the country who have produced the top all India ranks in the NEET examination, right? Not just for 1 year, from past couple of years. You are going to get trained by those teachers in this particular batch, which we are starting on 8th of August from Monday, right? By those teachers who have produced the all India rank. So it's my personal suggestion to get enrolled into this batch. It's going to be highly, highly, highly beneficial for all of you, right? And at the same time, my dear people, you can join the batch either through AI Live or Live Pro Lite or Live Pro Classic. These two, Live Pro Lite and Live Pro Classic, in these two programs, the classes will be live. And in AI Live, the class will be recorded. But during the recording, when you'll be watching the recording, there shall be a class teacher assigned to you who will be constantly helping you out in the doubt solving. And in Live Pro Lite and Live Pro Classic, you can ask your master teacher directly the doubts or whatever questions you'll be having during the session. Perfect? Right, my dear people? So do get enrolled into the batch, which is starting on 8th of August, right? It's a complete 2-year package, which involves your class 11th completion, then revision of class 11th, class 12th completion, then revision of class 12th, then crash course of 11th and 12th, followed by test series, followed by assignments, right? Followed by study material, followed by doubt solving. Every single thing is included in the batch. And at the same time, the best thing is you will be getting trained by those teachers who have produced the top all India ranks in the NEET examination. And my dear people, how do we get enrolled into this batch? Have a look exactly. See first of all. See, my dear people, this is the video which you guys are currently watching, right? Just a second, where did it go? Just a second. All right, this is the video, my dear people, which you guys are currently watching, right? The video which you guys are currently watching. Just drag it a little down. After dragging it a little down, click on more. After clicking on more, you can select your batch. If you are NEET 2024 English, click on the first link. JEE 2024 English, right? NEET 2023 English, JEE 2023 English, right? Whatever you want to select, you can do, right? For example, I'm assuming your NEET 2024 English. Click on the first link. After clicking on the link, just drag it a little down and select the course, right? Select the course. It seems that the batch is starting on 1st of August, but no, the batch is starting on 8th of August. It's a mistake here, right? They'll change it after some days, right? For example, just drag it a little down, click on buy now. Only few seats are left, my dear people. After click on buy now, you need to put your number, email ID, number or email ID, right? Better is to put your number on which you get the OTP, and eventually you'll be directed to the payment page where you have got a lot of options for the payment: credit, debit, EMI, net banking, whatever is feasible for you, right? You guys can get enrolled in as soon as possible. Perfect. But get enrolled before 8th of August because the classes are starting in this particular batch on 8th of August. That means on Monday, right? And your Vedantu classes won't be clashing with your school classes as well. The classes in this particular batch, which is starting on 8th of August, right? They will be after 3 p.m. So your Vedantu classes and your school classes, they are not going to clash at all, right? So my people, do get enrolled in this one. It's my personal suggestion for you all, right? So with this, I'll be taking a leave, and if you'll be having any sort of doubt, any sort of query related to this particular batch, you can ask me on my Telegram or Instagram. You know it, WASSIMBHAT, right? Take care. God bless you all. And